Hello, hello. In this segment, we are going to be focusing on dedicated entity turn ordering. We have a problem right now where the turn ordering allows enemies to attack simultaneously while their attack animations overlap. That might be desirable in some games, but that's not quite the design that I'm going for. I'll demonstrate that really quick, and then I'll explain kind of what's on screen right now. I'm going to surround myself with enemies here. And you'll see these two enemies below me attack me at the same time. They both move toward me, and their attack animations overlap each other. And in a real-time game, that makes sense, but this game is going to be turn-based, and there's technically no real problem with the enemies doing what they're doing right now. I get attacked, one after another, but I intend for each enemy or entity to take their turn for their attack animation to play and stall the other entities until one animation is done, then the next entity can take its turn and whatnot. But the problem we face is this guy right here. So our game is running at 60 FPS. The engine runs at 60 FPS right now. We have this array view over a list of entities. I guess I can show that in the code here. Get rid of this guy. Okay, maybe we can't show this and the terminal at the same time. Apparently not. I need to figure out what's going on with that. But okay, perhaps we can if I move this off screen here. Let's get this off screen for a moment. If we go into the game here, we have this entities data guy, which is backing storage for entities. I don't use truly sparse storage. I don't use archetypes or anything like that. I basically just use dense storage for all entities and all components. And then I have this view, and this view tells us which entities in the backing storage are actually valid. But this view is doing two things at once, right? So first of all, it tells us which entities are valid, as I mentioned. And the second one is that we're actually using that view to determine the turn order. So what we want is for an attack animation to prevent other entities from taking turns. And attack animations take longer than one frame. So therefore, we need to track the turn order across frames. And when we loop through entities again, we need a way to say, actually skip the first n entities because the n-1th entity just finished taking its turn, and now it's the nth entity's turn. But we don't have a way to do that in the current implementation. If the player is going to enter an attacking state here, then we'll set some properties on the player, and then we'll break to pass through the entities that determines whether actions are taken. Because the player always comes first, this break allows the player to stall everybody else when the player takes an action. However, the enemies come later in the loop. And so the question is, as I mentioned, if the n-1th enemy initiates an attack, how do we skip the entities up to the nth entity on the next frame through if n-1 finished its attack? And so I'm going to need to be extending the game state with some collection that tracks turn order. So I think I'm going to bundle this view into some kind of wrapper. The purpose of wrapping the multiple views is so that way we can pass around the wrapped collection, the bundle of views, instead of just these guys independently or one at a time. So if we ever need to update the view or update the valid entities, we can update the turn order collection simultaneously. Maybe I'll have something like this, entities. And that's going to be a view over entities such as valid, and then like turn or turn order or something like this. And the idea here is that valid will be what we're currently calling entities. It's just our view over the backing storage that indicates which entities are valid. And then turn will be a view over valid, which we will shrink as we process entities in their turn order. Yeah, so we have entity entities and entity components. That actually sounds pretty nice. Now we have to go check out where we set this stuff up. Game state entities data. We're no longer going to have an entities data. We're going to have an entities valid data. Is game state entities data. That is correct. And game state entities valid count. The player index is going to be, yeah, valid count. We just initialize that to 0 basically. That should run because we just essentially changed the aliasing for the backing entity storage, and it seems like it's fine. Now back in initialize, we do need to set the turn order somewhere. Maybe we just default the turn order to matching the valid view. So this would be game state entities turn. This is going to just get a copy of GS entities valid. So I think we do need to take a pointer to entities here. For timers, the turn order does not matter. I guess we can just keep the state transition here. I feel like this is going to introduce a bug, but I don't have enough data to make the right decision yet. We get rid of action taken here, and we put it in scope here, false, and we would just at the very end say something like if action taken break. We have continues though. I think continues are fine as long as we don't have breaks. So we need to get rid of these breaks, which is actually good because I don't want to be breaking halfway through a loop inside of an individual entity handling branch. So this will just be action taken as true right here. Yeah, movement. Okay, this is another tricky thing, right? Movement doesn't count as a stalling action. We want to allow everyone to essentially move on the same frame. So maybe not action taken, but rather action started. So movement is started and finished immediately on one frame. But if an action has been started, a prolonged action has been started, then we want to skip other entities. We don't want to allow them to move or take turns. So that does mean that either moving or taking a turn does count as your turn. So you pop off the turn view. The timing is becoming a complete mess here. Either that or it's actually very simple and maybe I just need to do more diagramming or something. I'm having a hard time keeping this in my head here. This action taken break is in the wrong place. Yeah, this needs to be one scope up here. So before we actually take an action, we need to reduce the turn view. So this will be entities.turn.count is -1 and entities.turn.data +1, I think. So we advance data by 1. We move, yeah, so that's basically a pop off of the view. Then we have to reduce the backing count by 1 if action taken. And we don't set that anywhere. In fact, we don't even define that. Action started, right? Started. Oh, wait, there's a break here. All right, I got to rethink this too. All right, this was kind of a hack. I kind of shoehorned in the select facing direction logic. It's just a very special case of movement. So if we break early, the player is going to stay in the turn queue. That actually is probably just going to work. Not pretty though. This is attacking, so action started will be true right here. Action started is true. Now at some point we have to restore the turn order if the turn order is empty. We just restore it there. This might have a gotcha where we restore the turn queue when technically everyone is taking a turn, but we are playing an animation. I overlooked something already, right? Which is the delete non-player entity thing. We do want to pass in entities, not just the valid. We want to pass in the whole collection, because if we do delete something from the non-player entity, we will want to find that thing in the turn order and also delete it. It no longer gets a turn. We pass in an entity index. This entity index is going to be, this is really interesting here. Oh, this is good. This is turning into spaghetti. This is not good. Turning into spaghetti here. So delete non-player entity. Check this out, because we're iterating through entities.turn. So this it index doesn't even make sense because we're making an entity view on entities.valid. We have to actually make the entity view on entities.turn. Actually might be better here in entities to not have this be a view over a view, but actually just be a collection of indices into the view. This way, whatever is remaining in the turn, these indices here, these are going to be valid to use in valid. Valid to use in the array view called valid. Right here we're passing it index, but if you look at what we're actually iterating through, it is entities.turn. So this it index is going to be an index into the turn guy. And the turn guy is a view over backing storage though. Let's explore that idea a little bit, see how that pans out. Go into game state. Similarly to the entities, this guy here, entities data, we need to have turns data. So GS entities turns data now gets GS turns data. GS entities turn count is going to be GS entities valid count. We're going to have that many. For 0 to GS entities valid count -1, we would do this. Because it is a view, we can actually do the following, right? GS entities turn at GS entities turn count is our iterator. So when we make an entity view, we just take it. We don't take it index. That would be a very sad bug. I'm probably going to shoot myself in the foot with this. Make entity view again. This is going to be okay, so it is going to get shadowed here, but we do have the entity view on the outer scope. So for entities.valid, yes, this is just going to be it, entities.valid. Now delete a non-player entity. Let's see. Okay, now we need to think a little bit harder about this because we need to introduce a wrapper here to delete non-player entity because we need to deal with decrementing the turn order as well, assuming that the enemy we attacked does have a turn in the turn order array. So, oh, right, because we're looping through entities valid, it's no longer it, it's it, it's it index, oh boy. And if the turn count is 0, we go and restore the indices for a turn, delete non-player. Okay, so now what we say is if the entity index is less than or equal to 0, or it's greater than or equal to entities.valid, valid.count, then we return false. Otherwise, the last index is entities.valid.count -1. And then we do an array unordered remove by index, entities.valid, we pass that by pointer. I think now we do the array unordered remove by value, I think. What does remove mean? I think I ran into this last time too. Like it appears to be a special word, remove it. I'm scared, but let's just use this. Okay, the array unordered remove by index. So that's going to be a pointer to entities.valid, entities.turn. The item is going to be the entity index, and stop after first will be true. Oh, array bounds check failed. Okay, wait, that's not what we wanted. So I was wondering if we would have to do this, and it looks like we are. So we increment the count by 1, and then I guess it is always going to increase monotonically, 0, 1, 2, 3. So I mean, this could just be it right here. It is it. Okay, well, I can't even move right now. Movement does not work. No source file, name entities.jai. So let's call it entity, I think. I swear I wrote this game. So something is taking a turn and stalling us, perhaps. P, entities.turn, data 0. That's 1. Okay, so we came through here and we say, if we are the player, then if we take an action, say that we started taking an action, otherwise we're going to perform movement, and the proposed position at the very first frame, I'm not trying to move anywhere. So if can move to, this is going to be false. We cannot move to the proposed position because the proposed position is going to be where I'm currently standing. Okay, so the player's never getting to go again because the player's not in the turn queue, and the ghost is gated on this. The player did not finish a turn, then just continue. The ghosts don't get a play until I get to go. If we actually allow the ghosts to go, then the ghosts are actually going to drive the movement, not us. Maybe I do preserve the concept of actually did something, like actually took a turn, moved or attacked, and then down here, gate on that. However, movement is a special kind of action. Movement does pop us off the queue, but it doesn't stall other people. There's got to be a more elegant way to propagate this information as actionable input, I guess. Return input.up or input down or input left or input right or action or select FD. Input has movement. That's not a good name, but you get the idea for now. Input has movement. Input might have movement, but even if input signals movement, I guess, even if input signals movement, then if we bump up against a wall or another enemy or something like that, we stop the player from moving, and I consider that not taking a turn. But this logic is not quite going to work that way. The kludge is coming together in my mind. So if we're trying to move, or input dot FD. Then we do this kind of stuff down here. Now we have to add another hack here, which is if can move to. So if we can actually move, then we consider ourselves having taken a turn. So this is our hack here, right? Break. We break out of the loop. That means we don't update any of the turn ordering down here. I press up. Okay, that worked. I can move once, but now I'm stuck. And I think we just returned to the situation that we were in previously. Once I move once, I get popped off the queue, and then the enemies have to actually do something. We might have to get the player finished a turn thing out of here already. Let's see, player finished a turn. So it's in 5 places here. Player finished a turn. We're just going to get rid of that. I don't even know what it's fully used for. Even though I wrote it, I forgot it. Okay, yeah, we were tying together 2 update loops. The whole idea of the turn order collection is to prevent that, though. So we're going to get rid of this. I have no idea how it's going to affect us right now. Player action cooldown. Player finished a turn. It is true that I finished a turn, although the blocking action animation is playing. This is the whole thing we're trying to clean up right now, is this spaghetti entanglement between these variables. Okay, so we'll get rid of that. Okay, but now we introduce a new hack. The player can move to a certain position. Get rid of this. We need to introduce this break here. Now, if the ghost has not yet taken a turn, and the action timer prop left seconds is greater than 0, it cannot take a turn. Okay, this one ghost is like moving double time here. None of these guys are participating. Oh, they get to attack. They don't get a move, though. Oh, okay, there we go. Let's see. The attempted index is 3, but the highest value is 2. All right, we're going to have to figure out what went on there. It is 0. So we're still in the player situation. So if we could press go next, we have entities, turn data plus 1. Okay, so now we're popping the player off the turns. We reduce the view size. If action started, it should be false. That is false. So press next for entities.turn, 733. I'll press next again. Action started is false. It, that's going to be 2. That's very interesting. Why is it 2? Turn data 0 is, oh, yeah, we're modifying the thing that we're looping over. We're popping the front of it, not the back of it. Oh boy. Okay, I also just realized that we have a bug in the delete non-player entity, because we assume that something that we delete is always going to exist in the turn queue, but it might have already taken its turn this turn. So we're back in the update states guy. I'm looking at the ghost. This is why he gets to go twice. Okay, so it's going to, I see, it deletes two entities through each pass through update states. That's why one ghost gets to go twice, and I get to go 0 times, or excuse me, I get to go once every time a single ghost goes twice. All right, so if we look at, I think we could monkey patch this just with a copy of entity's turn. So turns is going to get entity's turn. Then we'd say for turns here. And then here, I would say array unordered delete by value, and that's going to be turns. The value is going to be it index, which is, that is true. We're not deleting by index, we're deleting by value. So the value is it index. Just in case there was a guy waiting to take a turn that now no longer exists, we do this. And then we say stop after first. It's true. We need to assert that it's not equal to 1, that it is less than or equal to 1. So if I delete this guy, yeah, if we got some bugs there too, got bugs all up in this thing after I made those changes. I'm moving really fast now, or these guys are like, graphics are all messed up. Yeah, I think we could restore the data here. Entity turn data. It's going to be equal to game state, turns data. Oh, right, it's data. There we go. Well, it's actually not crashing. Okay. However, the update timing is totally hosed here. Oh, wait, these guys might actually also have cooldowns here. Okay, wait, these guys had cooldowns as well. So in fact, if I re-comment that out, and then I come down here and I uncomment this out. Now they should probably keep up, but now the game speed's probably going to be pretty gnarly. So indeed, yeah, they keep up now because I removed the cooldown. So I'll have to fix the cooldown situation. 1, 2, 3. Okay, so he gets to move twice. Interesting. Because like, yeah, I move once to the right and he moves and he attacks me. So there's a bug there too. Turns gets a value copy of the view right here. However, both turns and entity's turn point to the same backing storage. They just, because it's a view, the count is different. I'm changing the count. So when I change entity's turn by deleting the non-player entity here, our value copied view turns. Also, when we dereference the pointer to the backing storage, it sees the mutation. And this is ideally what we want to happen, but what's going on here is that all of a sudden the indices in turns are incorrect. The indices in turns are incorrect after this guy happens here. And what is item? Item is 1. Item is 1. That's what we expect. The iterator is 0. That is correct. So we'll go next again for array, next again. Now it should be 3. Oh, because, okay, we're never going to find 1 in here. Oh, I see. The reason we're never going to find 1 in here is, as I mentioned, the backing storage got changed out from under it. So we dereference the backing storage. Yeah, so I'm pretty sure the way I'm going about this is just complete spaghetti. And I probably need to abandon this or rethink this approach. But I'm like really close to the end. So I'm really tempted to just stand this up just to have something that sucks. Yeah, I see what's going on. It all has to do with the way I organize the data in the ECS. As I mentioned, I don't have any sparse storage. It's basically all dense storage, and the view over the entities is all contiguous. So when I delete a non-player entity, we just copy data from one index in the ECS to another index. The turns though, the turn order is getting messed up. This should actually, 3 should not come before 2. I guess we deleted the entity with ID 1. We should preserve 0 and then 2 and 3. So the guy with index 1 should be gone. Yeah, but we're shuffling this. So I'll just have to look at how I've implemented the deletion for this. When you delete something from a non-dynamic, like from a fixed size array, which is what we assume this view looks at, we assume it's not a view over a dynamic array, but it's just a view over a fixed size array. Then this remove thing, what it's probably doing is what this guy is doing right here, basically remove by index. So I'm thinking here, found and pause is array find. This is going to be the entities turn and pointer to turn. And then the item is entity index, pause +1 to entities minus entities dot turn -1. Shift down basically. And then we chop off 1 at the end here, I think, by saying entities turn count -=1. Found, if found, and the entities turn count is greater than 1. If it's equal to 1 and we quote unquote delete something, then we just modify the count so that way we don't get to see it anymore. Oh, that's because this is turn.count. Turn.count. Run. Okay, so all right, trigger that. Turns.data 0 is going to be 0, 1. Is that's already 2, 3. Okay, so this is definitely a logic bug here. We have 0, 2, and 3. So the backing data is already updated. I think now what we do is turns count -=1. Now we just delete the view here, delete this guy, and we still die. So now we need to look at why we're dying here. If we delete an entity, we have to subtract 1 from all of the indices. But the question is, where do we start? It works really well when the indices are already sorted, but it doesn't necessarily work well when that's not the case. We delete something in index 1. That means that index 2 and index 3 don't make any sense. We actually have to decrement those. So after we delete this kind of stuff, I suppose we say it -1 is greater than entity index, then -1 is -=1. 1, 2. All right, we live. Okay, so this was all just a bunch of noodling and spaghetti with indices and different backing data structures and all this kind of stuff. My voice is giving out a little bit. All right, signing off now. Have a good rest of the day, guys. Peace.